Hi everyone, this is Mr. Tam. I'm so glad that you're here to do some math with me. In today's video, we are going to work on AP Calculus BC free response question from 2022, and we're working on question 2. So let's get started. So here's question 2. A particle moving along a curve in the xy plane is at position x of t, y of t at time t greater than 0. The particle moves in such a way that d of t, dt over d, dx over dt is radical 1 plus t squared, and dy over dt is natural log of 2 plus t squared. At time t equal to 4, the particle is at the point 1,5. So first off, the question about a curve on the xy plane. That is a parametric curve problem. Okay, it's always a good idea to understand what type of problem you're working with so that you can kind of think of what's important to answer the question. So clearly this problem gives us the two derivatives right here. An interesting thing to note is the following. It gave us that at t equal to 4, we know this. So this basically tells me that x of 4 is equal to 1 and y of 4 is equal to 5. This is usually kind of referred to as an initial condition. So when you given a derivative of some functions, and you also given some kind of value for that function, is a classic example that you will be using fundamental theorem of calculus to actually try to answer a question. So we'll probably see later on in the problem we're going to use that. All right, but let's get to the problem. Let's start with A. Find the slope of the line tangent to the path at the particle at time t equal to 4. So that is essentially looking for dy over dx at t equal to 4. So based on what you hopefully remember from your class, dy over dx is actually given by dy over dt divided by dx over dt, and I can evaluate that at x equal to t equal to 4. So since both of those two things are given, I'm just going to plug them in. So that means the natural log of 2 plus t squared over radical 1 plus t squared. Evaluate t equal to 4. So 4 squared is 16. So that's natural log of 18 over square root of 17. I do believe you can actually give that as an answer, but if you want to give a decimal answer, you can. Just remember that you need at least 3 decimal places, if not more, just to make sure that you don't get penalized. So here I'm going to just do that too. I do like to use a fraction template whenever I need to put in fractions, just so that I know I didn't make any silly error. These are habit that I developed to help me do better in math. So this seems out to be, oops, forgot the decimal or the 0. I like to write 0 in front of the decimal. 0.701 dot dot dot. So either one of these should be acceptable, really depending on what you feel comfortable giving. Because the calculator part of the exam, I usually give a decimal answers. That's just me. Let's see. B. Find the speed of the particle at time t equal to 4 and find the acceleration vector at time t equal to 4. So that's two-part question. So let's answer the first one first. So once again, speed is actually given by a formula, which is this formula. If I'm not mistaken, you might have learned 2 different formulas for speed. The one that we want to look for or use right now is the one for parametric curve, which is this one right here. Your teacher might roll it dx dt first, then dy dt. For whatever reason, I write dy dt first. There's a second speed formula, but that will be using df over or dy over dx. So that's not this one. So in here, all I really have to do is just evaluate this expression at t equal to 4. So that's square root of natural log of 18 square plus square root of 17 square. So once again, it should be okay if you just stay like that, because in BC exam you don't really have to simplify, but I'm going to just put in a decimal just so that I have a numerical value for that. So I'm going to say this is radical 17, because that radical 17 square is 17, plus parenthesis natural log of 18, close parenthesis, square. I do believe you need a second parenthesis because I don't know if the calculator would interpret an 18 squared then natural log. I'm not sure, so I just like to write it the way I did just to make sure. So that come out to be 5.035. All right, so that's easy enough. Now acceleration would just mean the derivative of the derivative. So acceleration vector would basically equal to d square x over dt square, and then d square y over dt square. So essentially want to also evaluate it at t equal to 4. So that just means you're looking for the derivative of the equation given to you at 4. So once again, what you want to do is simply just to use your calculator for this. So I'm going to just do that. The command that I'm going to be using would be actually, you know what, let me see. I mean, the function is easy enough that we can just differentiate, I guess. I'm going to say this is t over radical 1 plus t square, if you take the derivative of that, because you, okay, well, maybe I should, okay, maybe I'll write out the step just to be safe. So if I have dx over dt equal to radical 1 plus t squared, that means is 1 plus t squared to 1/2 power. D square x over dt would equal to 1/2 1 plus t squared to the first multiplied by 2t. I'm sorry, negative 1 over 2 to 2t. So that basically come out to be the following. The 2 and the 1/2 cancel. So we have t over square root of 1 plus t squared, because that's what to negative 1/2 power means. The second one is easier. Dy over dt equal to natural log of 1 plus or 2 plus t squared. So then the derivative of that would be just be d square y over dt squared. That would be 1 over 2 plus t squared multiplied by 2t. So it's just 2t over 2 plus t squared. So if I just evaluate at 4, look to me, it should be 4 over radical 17. And then 4 times 2 is 8. 8 over 18, so 4 over 9. And so here's my velocity vector, acceleration vector. All right, that took up that. C, found the y-coordinate of the particle position at time t equal to 0. Now that is exactly what I was talking about with the initial condition and the derivative. Whenever you give an initial condition and the derivative of some functions, then it's very likely that on the BZ exam, you're basically doing fundamental theorem of calculus. So here, the fundamental theorem of calculus is the following. So we are given dy over dt, which is equal to natural log of 2 plus t squared. The question already gives us that y of 4 is 5. And the question asks us what is the position at 6. Oops. Y of 6. So the easiest way or the best way to set up the problem is to actually use what I like to call fundamental theorem of calculus. So here we talk about 2 different time intervals that you're working with, 6, 4, and 6. So I'm going to do is I'm going to say the following. I'm going to say integral from 4 to 6 natural log of 2 plus t squared dt. So that would be integrating dy over dt, but go from 4 to 6. That would give us y of 6 minus y of 4. Since this is what we're looking for, what I'm going to do is I'm going to move this to the other side of the integral. So therefore becomes y to the 4th plus integral 4 to 6 natural log of 2 plus 4 2 plus t squared dt would equal to y of 6. So now here is where you're going to be using your calculator to calculate this numerical value. Oh, look like my calculator shut off. Let me reopen it. Okay. There you go. Now it's perfect. So now all I have to do is just use my calculator to integrate this. And since I already know what y of 4 is, because y of 4 is 5, so I'm going to say this is 5 plus, and I'm going to go and clear this out. I'm going to set up my integral. So math, FNINT, function integral, 4 to 6, and natural, oops, 4 to 6. Here we go. Natural log of 2 plus x squared dx. Do not attempt to integrate this by hand because you are on the calculate part of the exam. You are expected to use your calculator to evaluate any of these integral. So don't try to do it by hand. Just use your calculator for that. That's what it's for. And more often than not, you'll be given an integral that you cannot integrate. So 6.5705170004. So that's equal to y of 6, which if I just add that f5 to that, I will have my answers. And I don't think the question asks us to round to anything specific, so 3 decimal places is what we're expecting. So 11.570 dot dot dot. There you go. That was easy. All right, let's see what the last part is. Find the total distance of the particle travel along the curve from time t equal to 4 to equal to 6. So the way to do that is to use the total distance formula. The total distance formula has an integral for that. So once again, these are things that you have to remember. And the distance travel, which I don't know what your teacher might use for oh, actually, you know what? Let me make this smaller. So that, there you go. I don't know what your teacher use. I usually use L because it's kind of stand for arc length. Is equal to integral from a to b square root dy over. Okay, you know what? I'm going to write dx over dt. Dx over dt square plus dy over dt square dt. So that's usually called the arc length formula or the total distance travel formula. And you might notice that the inside of this integral is basically the speed function. So you're integrating speed, you get distance. So that will be equal to, in this case, what are we doing? 4 to 6, I think. Yeah, 4 to 6. 4 to 6. The integral of this is dx over dt, so radical 1 plus t squared. Square plus natural log of 2 plus t square dt. So absolutely do not try to integrate this by hand. That's what you have a calculator for. So I'm going to just find that. So I'm going to use my calculator to do this. We'll clear this out. So I have room, math. There you go. 4 to 6. Go say parentheses. Well, you know what? The radical just cancels, so I'm just say 1 plus x squared plus. So, oh, I'm going to just put the x here for now. Okay, plus this one I do need a parentheses. Natural log of 2 plus x squared close parentheses square. And I'm going to hit enter. Yep, I forgot the square root. So let me see, I just want to make sure that, okay, I have an open, big open. So I guess I just have to put a square root out here. Oh, no, I cannot. So I'm going to have another one. And an open, and oops, I have to add a parentheses so that I can put a 1/2 power. There you go. There you go. Now I have to put a 1/2 power to put in the square root. Oops. 1/2. There you go. Now we have the answers, which is 2.136 dot dot dot. So I think that's my arc length. So I would say, let me see. Yeah, I'll probably just say something like this. The distance traveled by the particle from 4 to 6 is 12.136. The distance traveled by the particles from t equal to 4 to t equal to 6 is 12.136. And that would probably be my answers. None of these really require word. I think we are good. All right, that's it. All right, see you in the next video. Bye bye.